Welcome to Study Loop.
Problem 8.55. We have this assembly in some sort of machine. We have a bar that's horizontal, another bar that's vertical, and at the end of this bar is a heavy weight, or heavy relative to its size. So what we want to do is figure out where the center of how much the center of mass moves when the bar or the hinged whatever goes from this configuration to this configuration with a rotation like that. So let's set up some coordinates. It's easiest to center them at the hinge, so that's what we will do. And it's also easiest to have X and Y running along the initial positions of the bars. So the initial X component of the center of mass is going to be the sum of all of the weighted sum of all of the X components of the things here. Now, because we've put X equals 0 here, the vertical bar doesn't contribute anything to the X center of mass in this position. So we can treat this as a point mass halfway along its length. Let's actually write out if we call this 1, this 2, and this 3, then it's m1 x1 plus m2 x2, which is 0, and m3 x3, which is also 0, but we have to add up all of the masses. Because although their X position is 0, that means that they actually have to bias the center of mass towards them still. And then if you put all of the numbers in, we find that this is 1/3 of a meter. 3 meters. And just to reiterate, the X's are going to be for the ball, it's just the center of the ball, and for the bars, it's halfway along the length of the bar. So that's all good. Let's use some space up here, maybe. So now the initial Y is going to be m1 y1, which is 0, because this is on the y equals 0 line. And then m2 y2 plus m3 y3, 2y2 plus m3 y3 divided by m1 plus m2 plus m3 . And this is 0.7 meters. Now we turn our attention to here. Recall that this will be our x1, y1, x2, y2, and here obviously is x3, y3. And now we can see that there's no y component to anything. because all of the masses are now entirely along the x-axis. So that was easy enough. And now, so this is the only thing here that's any different is that we need to recall that this is the positive direction in x, so that these now have negative x coordinates. And let's call the new ones primes, I guess. This one hasn't moved, but the other two have, so M2, X2 prime, M3, X3 prime, divided by M1 plus M2 plus M3. And then putting the numbers in and recalling, like I said, being very careful that X2 and X3 are negative, because this is our origin. And we said that the left of the origin is positive x, and so right of it is negative x. We get that this is negative 0.366 meters. So let's just carve out some space here. The change in the x-coordinate of the center of mass is the final minus the initial. So x final minus x initial. And so 0.333 meters minus negative 0.366 meters is going to be 0.7 meters, so 3 digits. Meters. And then delta y is the final, which we said was 0, minus y initial. So just plop a negative sign onto that. And so now we can see that it moved it. No, I'm sorry, I'm mistaken. This is negative, and that's positive, because this went, the center of mass moved to in the negative x direction. Excuse me. Oh, right, because this was, oh, yeah, because x final is negative, and then that's positive, more negative. And then oh no, this is also negative. Because down is down the positive y direction, and it moved upward. Anyway, so it moved 0.7 of a meter and y. And then if you like to get the actual magnitude of the displacement, you can use the Pythagorean theorem, but we're not really asked for that in this problem. So we won't worry ourselves with it. It's also a fairly simple thing to do, and if you want to know what that is, it's good practice for you.